G'day team, welcome back to another video, and again we are continuing on with the unit circle. So this is sort of part 2 of chapter 5C that we're going to run through. There was a lot of information in that first part of this video, so please make sure you go back, watch that video. It is sort of kicking off this whole unit circle work. So now that we're all over finding the coordinates of points on our unit circle dependent on angles, all right, we're now going to look at the periodicity of trig ratios. So one thing you'll find is a lot of the angles are very similar. They'll have the same value, might change a negative sign here or there. But the periodicity of trig ratios is actually really cool to look at, okay? So as there's 360 degrees or 2 pi radians in a full revolution, if we add 360 degrees or 2 pi radians to theta, respectively to angle measurements, so if we are in radians, we would add 2 pi. If we're working in degrees, we'd add 360. The position on the unit circle does not change, okay? So if we're looking here, I've got my original angle theta. Now, if I add 360 degrees to this theta, or theta plus 360 degrees, see how we're in the same spot, okay? Same thing if theta was measured in radians, in fact, and we added 2 pi radians, we would again get back to the same spot here. All right, so for any variable k that is an integer, so this means it's inside the set of integers being whole numbers, so 1, 2, 3, 4, etc., or negative 1, 2, 3, 4, okay? Cos theta plus 360 times k degrees, so any whole multiple of 360 is also equal to cos theta, okay? So if k is 1, then this is just 360 degrees. If k is 2, then it's 720 degrees, and that's 2 whole revolutions, okay? And then sine theta plus a k times 360 degrees as well is also equal to sine theta, okay? So if you see somewhere in a question that's find cos of theta plus 360 or plus 720, then you know it's just going to be the same value as cos theta, okay? Now, so that's in degrees. In radians, same thing, except instead of 360 degrees, we have that factor of 2 pi, all right? So same result, except we're now using 2 pi instead of 360 degrees. I've also got a couple other cool little periodicity results or formula that you might come across as well. So if you're adding 180 times by some k degrees, so 180 or 360, 540, so 180, 540, things like that, then you actually, the cosine of that is going to be negative cosine of just theta, and then same thing with sine. So that's for degrees up the top, and then this one's for radians. So remember, pi radians is 180 degrees. K times pi, you're going to get that negative cosine or sine value. Tan, however, if we're adding a multiple of 180, will give us positive tan theta. Okay, so 180 degrees, pi radians, okay? So if we're only moving half a revolution around the circle for tan, then we're just going to get that result of tan theta again, all right? So a couple of examples. Find the obtuse angle with the same sign as 63 degrees and pi on 4 radians. Now, let's first of all draw out what is actually going on here. So if we just put a little axis in here, and then a little unit circle. All right, line him up a bit better than that. Beautiful. All right. So 63 degrees we know is over halfway between the first quadrant. So we're looking at that there. All right. Hopefully from the last video, you guys remember that the sine value is the y coordinate. So we want something that is the same y coordinate. So y coordinate to there, and we extend this over to here. So that means the same sine value will be created there. All right, so what we need to look at is this whole angle in here, okay? My dot's a little bit big for you to see maybe, but we're finding that whole angle there. So we actually need to find this angle in here. And the beauty of our unit circle is it's all very symmetrical, even though my diagram doesn't look like it a lot. So the angle inside of here is actually equal to the angle inside of here. And if you know this angle in here, we can add it to 90 degrees to find the whole angle. So this angle in here is actually, in fact, 90 take away 63, okay, which is 17 degrees. Now, if that's 17 degrees, this one here, then this one here is also 17 degrees. And that means our whole obtuse angle, okay, is 90 plus 17 degrees, which is 107 degrees. Okay, so 63 degrees and 107 degrees actually have the same sine value, okay? Now, pi on 4. If you guys can remember your unit circle, okay? So put in our circle, put in our axes, might not be super straight. Pi on 4, so we've got pi on 3, pi on 6, pi on 4, pi on 3. So pi on 4, smack bang up the middle. Again, because we're looking at sine, we're coming across to that y-axis and moving all the way across. So that means, get my right color, means we're looking at this whole angle in there. So pi on 4, hopefully you guys are starting to remember a few of these quick conversions. So pi on 4 is actually 45 degrees. Okay, so 45 degrees. What I'm going to do, I'm going to convert to degrees just to showcase our same trick as before. So we're going to work in degrees as well. So remember, if this angle here is equal to this angle here, all right, due to symmetry, that means the whole angle here is 90 degrees plus this angle. We know that angle is 45 degrees, so 90 plus 40, that's not a 5, 45 degrees, 135 degrees. So pi on 4 has the same sine value as 135 degrees. And if we do a quick conversion back into radians, 180, that's going to give us 4 pi on 5. Okay, so 45 degrees, pi on 4, 135 degrees, 4 pi on 5, they all have the same sine value. All right, so hopefully, once you finish going through some of these questions, you'll discover some of these properties. So I'm going to say them for you now, just so you can keep your eye out for them. All right, so sine of 180 degrees, take theta equals sine theta. Sine of negative theta equals negative sine theta. Cosine of 90 take theta equals sine theta. Cosine of 180 degrees take theta equals negative cosine theta. Cosine of negative theta actually equals cosine theta. And then sine of negative take theta, 90 take theta, negative take theta, 90 take theta is equal to cosine of theta. So hopefully all of these properties you'll be able to use to answer the next few questions throughout the chapter. All right, so please have a crack through 5C questions 5, 6, 7, 8 and 9. Don't worry about the odds and all right? Please just do 5, 6, 7, 8 and 9. All right, we'll see you guys in the next video.